7, 6, 5, 4, 3, 2, 1, and liftoff of the Cassini spacecraft on a billion-mile trek to Saturn. Things are go.
Just a sec, Mark. Good morning and welcome to the 2019 CosmoQuest Hangout-a-thon. My name is Dr. Pamela Gay and I am here to put science in your brains. Today and tomorrow night for 40 straight hours, we will be here bringing you science guests, artists doing science adjacent work, and all sorts of crazy content, including the unboxing of a new gift box series you can get from Astronomy Magazine. We have 4 of those to give away. And oh yeah, we're going to have a giveaway about every 15 minutes down in the chat. Now, I have to admit, we have an amazing team, and that's not really a great admonition, but our amazing team is entirely running the raffle, so I'm not entirely sure how it works. So follow along the mods in the chat. Susie, Nancy, the amazing Paranor, who is the Banhammer extraordinaire, they're going to be running all those giveaways. Now, we're going to start today with a discussion of, well, CosmoQuest, who we are, the Planetary Science Institute, where we are located. We're going to talk to that CEO so you can find out what exactly it means when I say this is brought to you by the Planetary Science Institute, a 501c3 nonprofit dedicated to exploring our solar system and beyond. Now, let me go ahead and switch things up so that I can bring Mark on screen. As I said, I'm running solo this morning, so this is going to apparently take me more effort than thought because it's just not, it hasn't had its coffee yet. There we go. There we go. Hopefully the audio will come with me. All right. So good morning, Mark, and thank you so much for the 300 bits, Keeper of Maps. This is, after all, a fundraiser. We will have doggos here later. As I said, I'm the only one in the house currently awake. And Mark, it's an hour
no dogs
earlier where you are in Tucson, Arizona. How are you doing this morning?
I am doing just fine because I'm having my coffee. So
That-
it's my there we go, and there's my coffee. Yeah.
So watching out on the Twitch screen, you're going to see a 30-second lag on what you're seeing face to face here in Zoom. Maybe not 30 seconds. It all depends on how fast their servers are running. So
Right.
I
I'll
really
just
appreciate
it.
you being here.
Oh, it's a pleasure to be here. It's I love this hangout-a-thon. I've never experienced it for the first time last year, and was very impressed, and love all the people that contribute to it.
So every, or at least most Mondays through Fridays, our audience hears me say the words, we are brought to you by the Planetary Science Institute, as 501c3 nonprofit dedicated to exploring our solar system. And I throw on the and beyond because exoplanets, stars that planets orbit, those are beyond our solar system. Now, you've been with the
But we
Planetary
buy
Society
into it.
for, go ahead.
Oh, I was just going to say, but we're not just the hood, not just our solar system, but solar systems around other stars too. So we're a pan-galactic organization.
So can you tell our audience a little bit about the origins of the Planetary Science Institute and the vision for where you're hoping to go?
Well, we started in 1972, so 40, whatever that is at this time in the morning where I'm having my first cup of coffee, 40, some odd years ago, 46 years ago, or 7 years ago. There we go. And by a couple of people who didn't want to be part of the University of Arizona bureaucracy. They wanted to have their own thing so they could focus on research here in Tucson. And so they started PSI. And for decades, it was a small, outfit with like maybe a dozen people, or so in it. And then over the last 15 years, we've been growing to where today we're not just in Tucson, where our headquarters is, but we're in 31 states, 11 countries. We have 150 employees, 110 PhDs. We're involved in all the NASA missions and international missions as well, exploring other planets. We have people working on Hubble Space Telescope, Spitzer Space Telescope, other ground-based facilities. We have people scattered about the world doing field studies because one, Earth is a planet, and two, we learn about other worlds by studying processes here on the Earth, and it goes the other way too. We learn about the Earth by studying how things work on other planets. So it's a very it's a lot of fun, a lot of great variety of science out there, and astrobiology too. And we have people that try to understand, how did life arise? Where do we find it? Isn't it amazing if you drill a kilometer down into the rock, we still find bugs? And what does that say? So it's an absolutely fascinating field that covers chemistry, physics, biology, astronomy, and our organization is doing all of it, and we also support people. Like I said, we're in 31 states, and that's because that we're both brick and mortar, but we're also distributed, and so we support people such as yourself in various different locations, because why should we require everybody to be in the same building? We have this thing called the internet these days, and so it works out very well to create a community of people that are distributed.
And one of the things that I'm really coming to appreciate more and more is just how diverse the population of people at the Planetary Science Institute is along most axes of the word diverse. You have a huge number of women, almost 50% at the PhD level.
Yeah.
And I've never seen that anywhere else.
Well, in our profession, it's about 25%.
Right.
But at PSI, we're always pushing up against 50%, and so for us, that's just normal. It's not something that we created an environment that's not just good for women but for men as well, and people find it very supportive, and like I said, we have a community, and our goal is our purpose is to help each other out, and so one of the funny things with that we do is, because we have people scattered all over the place, we're the solution to what people call the two-body problem. At universities, real classic issue. One spouse, usually the guy, gets a position someplace, and his wife has to figure out, well, do I continue my career or do I continue my marriage? Right. And whereas we don't care where people live, and so that solves that problem. But the interesting thing is that at PSI, we actually have more men following their wives around than wives following their husbands around. So
that is amazing. And as someone who has a two-body problem, I have to say thank you. My husband may not be an academic, but he certainly is the person who has the income that matters in this household. And one of the things that
you have the societal impact.
Yes. So one of the things about PSI that we try and communicate a lot is academia. You get paid in a lot of different ways. You get paid for teaching classes. You get paid for some of the administrative work you do. And if you aren't teaching faculty, the majority, if not 100% of your salary is going to come from grants, from sponsorships, from donations. And at the Planetary Science Institute, there's none of the squabbling that I've seen at universities, because everything is just laid out flat. Here are the rules, no exceptions. You get promoted based on how many years past PhD. Here are the salary guidelines based on national averages. It's just laid out on paper, which means that instead of squabbling for the limited resources that often happens, instead I've seen, I don't know how many emails of, hey, I'm available, I can help. And people saying, hey, I need someone to help. And there's this academic matchmaking system going on of intellectual skills to intellectual needs. That's amazing. How did you and your predecessors foster this amazing community of let's get rid of the bureaucrats and just focus on the stuff we want to do?
Well, PSI was always like that, and it was much easier when it was like 10 people, and that includes admin staff. And so, because they just sit around a table and decide whatever needed to be decided and all that. Now, people didn't think that we would be able to maintain that kind of culture as we started to grow. And I think that we've demonstrated now that we're more than 10 times bigger, that no, it works just fine if you foster an environment in which people are supportive of each other, where the scientists and the work that people do has the priority, from an institutional standpoint. The main question is just how can we support you rather than, what's your status and what do other people think and all that kind of stuff. I was at a university for a number of years, and I always like the expression that the fights at academic institutes are so vicious because the stakes are so small. But
yes.
but yeah, I mean, you're right. We don't have any subjective criteria. When I was at a university, I was asked, if I was going to be promoted, had to get letters from people around the country, in some cases around the world, when I was going for the equivalent of a full professorship. Whereas at PSI, we just say, no, if you've survived for 10 years past PhD, you're a senior scientist, thank you. And we also don't, we allow people to set their own salaries, which sounds kind of strange, at least on the scientists and stuff, because we have people joining us from academic institutions where the salaries may not be that great, but we also have people joining us from like government labs where the salary is in the category of, oh my God. And, and so I don't want to tell people, because they have to bring in the money to support their salaries, that, hey, double your salary or cut your salary in half. It's like, no. And so me and our HR manager, Linda Ruger, every year, we've got some databases that we're subscribed to. We go out and we create, kind of a model planetary scientist, part physicist, part astronomer, part geologist, part, all that, so I was like Frankenstein's monster. And we find out what's the average salary for this conglomeration of a person as a function of years since PhD. And that's our guideline. It's not what we require everybody to do. We just say it out. Here's the guideline. If you're above it, great. Be good to yourself. If you're that's all good. If you're below it, then it's like, maybe you ought to be better to for yourself. Because frankly, I've been through law school. I've seen a lot of medical school stuff, and getting a PhD in the physical sciences is as or more challenging. And so, I think people deserve to be making a reasonable income. And so, but a lot of people in our field, they feel guilty, for doing things that they really enjoy doing. Because when you're out there discovering stuff, when you're exploring and you're learning new things, it's so intrinsically rewarding that it almost feels bad to take money to do it.
Well, and to be frank, many of us have been told by past employers, you're lucky to have this job. How many people would kill to do what you do? And unfortunately, occasionally have killed. But you've given me the freedom with my staff to work on, paying them a living wage, and we're working towards an average wage for each of their different
average wage.
It's morning. Wage. Can't talk yet.
Yeah. More coffee. Yes.
And part of doing that is being here, where we are raising funding to make sure that everyone working to do science communication, citizen science, and to invite all of you in our audience to be part of exploring our universe and beyond.
And we
Well,
absolutely, oh, sorry, we absolutely enjoy having CosmoQuest as part of PSI now, and you, Pamela, and your people, Susie and Annie, and everyone else, because it really kind of expands the dimensionality of how to get information out to people, and I think it's really terrific what you do with this platform. Uh,
and and we're working on finding ways to. We have now conquered Bennu. It's I see folks in the chat saying rage on Bennu. Uh, Not going to lie, there is a call and response I discovered among my staff. I did not know this was happening until we all went to attempt to watch rocket launches last week. And if you say Bennu, the response, as though you were in a church, is everyone around responds not what I'm going to say, but they say the full word, F Bennu. And then someone will say, as the final response, so many rocks. And this is because in 91 days, we marked more than 14 million things on the surface of Bennu. And that's a
So
lot.
very impressive, very impressive, and I want to commend all your participants on CosmoQuest that made that happen, because you provided fundamental information for a nearly $1 billion mission to achieve its goals of finding a place to sample the surface, and so yeah, you don't need to be a PhD to participate. You can make a substantive contribution through what you were offering, what you were creating here with the Binu Mapper project. And so absolutely great. And I hope that, and I really want to thank all those people who stepped up there and made all those 14 million measurements, because it couldn't be done without them.
And I'm going to talk about that for just a moment. I do want to take a station identification break to say, for those of you who are just tuning in, you are watching the CosmoQuest Hangout-a-thon right here on twitch.tv. We are going to be spending 40 hours working to raise funds for science and science communications. Here at CosmoQuest, we work to bring you the universe and to invite you and help us in that exploration. We have completed mapping out Bennu, and we are working to plan many new programs for the future. But to make that happen, we need a little help from you. We need to raise roughly $40,000 between now and we'd like to do it by the end of December. To make up the difference between the monthly income that we bring in through Patreon and other donations and what we actually need to pay all of our staff for all the hours they put in to bringing you all the content you see. If you can give, please do. If you can't, we totally understand. You're still welcome to enter the raffle. And I see we just finished giving away a Planetary Science Institute backpack, and a new giveaway is the current giveaway is a PSI backpack. So you're still welcome, but please, can you share the good news or the bad news or the sideways news that we're trying to raise funding? So please give if you can, share if you can't, or if you can, just share the news and let's celebrate some science. Now, Mark, you are a scientist and you're also a communicator, even if that's not how you bill yourself. And you and your organization, which is now my organization and Susie and Annie's organization, one of the things that we do is we communicate science as well. What tell me your thoughts. I know you're working on doing a new vision for it at PSI, and I just want to hear it in your own words.
Oh well, I don't know. There's always new visions coming up. It's part of what we eat and drink. But yeah, now that we have you guys on board, then I'm really looking forward to try to get our scientists more engaged in things like podcasts and because scientists like to do their work, but dragging them to and then some like to give public talks. I love speaking to the public. It's always fun, and kids in schools and all that. But we do a lot of work. We publish a lot of papers, and so I would really like to see a steady stream where our scientists could talk about it, or to get them to talk about it, because that's something that everybody should be doing, and to learn that this is good for them to appreciate that this is stuff that everybody would like to hear about, and whether it's tsunamis on Mars, or what we've learned about the Saturn's magnetosphere, or whether there could be where there could be water resources for humans to make use of on Mars, or how things form, or how life arises. I mean, people are in the technical details. They kind of like, oh well, but this is too technical and boring and all that kind of stuff. No, it's interesting. It's fascinating, and you should put yourself out there and talk about it. And so having, bringing your crew on board, I think gives us that opportunity to expose these people to a more easy opportunity to get the word out. And so that's kind of my goal is to ultimately make communicating to the public easy and regular, within the Institute. So, and not just for those of us like you, like me, like many others, but not everybody, who love to go out and talk to public audiences.
And we will be having some additional Planetary Science Institute researchers on throughout the Hangout-a-thon. We're going to have Julie Rathburn coming on to talk about volcanoes, including Loki volcano on Jupiter's moon Io. This is one that she actually has been studying her entire career and has helped figure out its regular pattern of eruptions, which is something that Earth volcanoes aren't consistent in doing, but Io is its own entirely different world. We're also going to have George Kramer. She will be talking about moon, lunar swirls, and so many awesome scientists will be joining us. Sorry, I had a bing going off in the background. It should be dead now. Death to the bing. So I do want to thank those of you who have already been helping out today. Sami Dijap, thank you so much for 8 months of subscribing. Mark, thank you for what you have given that got us over that $1,000 mark. And thank you, Keeper of Maps, for the 300 bits. I'm sorry, I don't have a dog right now to throw bits to. Life is good. So one of the things that we've been working on is writing federal grants. And I think late last night, we finally had that budget signed into, I guess, law authorization 20 minutes before midnight East Coast time. I had a slow meltdown watching it not get signed until the last moment, not going to lie. And
you never know what's going to happen.
Oh, my goodness. Well, last year we went live with the Hangout-a-thon just as the government shutdown started. And that was horrifying. We're in a better place now, thanks to that pair of signatures on that pair of bills. And we're hoping to hear about new grants that are going to help people explore through observational astronomy, doing photometry and astrometry of asteroids, variable stars, and other things that blink and fly through the sky, including Betelgeuse, which we'll talk about at some point, because it's currently fading. Have you heard about this, Mark?
No, I mean, well,
Yeah.
it's a big star, but I haven't heard that it was getting fainter.
It's visually fainter. It's dropped a couple of magnitudes.
Really?
Yeah, yeah. So
Is there a
so
giant spaceship that's getting in the way?
no, but so there's a few stars in the sky. For those of you out there who aren't into stars, I get it. Planets are cool too. Um, if you go out pretty much anywhere in the world, because this is an equator constellation, you can see Orion. He's from the southern hemisphere, dude standing on his head. From the northern hemisphere, he's upright. If you're on the equator, he's lying on his side. There's 3 belt stars, a sword of nebulosity hanging off, and these 4 bright corner stars that are his shoulders and his feet. One of those corner stars is extraordinarily red. It's Betelgeuse, Betelgeuse, depending on where you are, how it's pronounced. And this giant red star is one of the top 5 most likely to go supernova in our lifetime stars. And so we watch it and joke, this is never going to happen in our lifetime, but it would be cool. And we don't know what's going on. We don't know why it's dimming. It has been a variable star. It varies in magnitude by about 1.5 magnitudes. That's a factor of more than 10 because astronomers like to do things in logarithmic systems.
What's its period?
It's a red giant, so it's order of years. But
Okay.
it is currently fainter than it has been in recorded history for this star, which is well over 100 years. So everyone's going, blah, what is this red giant doing? It's probably not going to go supernova. It's probably just going to be exciting. But these are the kinds of discoveries we're going to help people like you be part of making. The grant that I'm talking about right now is Transient Trackers. It's to write software. We also have other grants pending to study the ethics of citizen science, to work with Planetary Science Institute scientists to develop more citizen science tools and put everything we do here at CosmoQuest open source. And even if we don't get that grant, we're still going open source to invite you to help us out and to invite other scientists around the world to become part of using citizen science to allow everyone in the world who always said, I wanted to be a scientist, but then for various reasons went off and did something else with their life, to live out that goal of being a scientist. Now, what got you into doing science, Mark?
Well, shit. I don't know. Watching, I hate to say it, dating myself, watching Alan Shepard go up.
That's fair.
Back,
For me, it was
back
the space shuttle.
61 or something, and I actually watched through just sheer luck every human American space launch from Alan Shepard to the space shuttle.
Oh wow!
To the first space shuttle launch, and so that was something. And actually, speaking about variable stars, I started out life as an undergraduate measuring variable stars, eclipsing binaries. And that was my job in the summers, was to go up for 3 months to a small telescope in Central Oregon and do photometry, with a, photo tube, and where slewing the telescope was eyeballing and jumping around the stars to get to the prime target that I was observing was HD 226868. Which was the home of Cygnus X1, the first black hole system that was ever discovered.
Yeah.
And so so I did that for years. So I'm still interested in variable stars. And these are 2 stars. The stars like I think Betelgeuse, they vary because of oscillations in the atmosphere, and eclipsing binaries is two or more stars that are orbiting each other, and sometimes they get in their way along the line of sight, and so you see the total brightness of the system varying as they move around. Also, they get, if they're really close together, the shapes of the stars get distorted. And in the case of the black hole system, HD 226868, the blue giant that refers to actually fills its Roche lobe. So it's kind of a teardrop shaped thing. And then at the pointy end of the teardrop, there's material that's leaking out and then orbiting the black hole and then being absorbed by it. So all cool stuff.
Yeah. And what is really amazing me is all the science that you and I learned initially as variable star science is now becoming exoplanet observational techniques. Those very careful measuring the radius of a star by looking at the shape of one eclipsing the other. We're now using that to measure the diameters of planets. We're finding that some of these massive Jupiters are filling their Roche lobes. Who thunk that would be ever a thing?
Well, and the fact that the measurements are so sensitive these days. One of our scientists, Tammy Rogers, I believe it was, that was measuring how hot the side of the planet is facing the star, and you could determine that because it gets covered up, when the back of the planet is facing you, and then exposed, and you can actually, even though this is really faint relative to the brightness of the system, measure the temperature. And then she's using that to actually to do models of the atmosphere and to constrain the magnetic field strength of the planet. It's like, oh my God, it's just absolutely remarkable science that can be pulled out of these observations. And of course, with JWST going up, hopefully before nuclear fusion comes around, it'll be able to make observations of some of these individual worlds and hopefully do some spectroscopy to see if there's evidence of life on the surface as a consequence of the evidence produced in the atmosphere. Or that manifests in the atmosphere. So, a lot of good stuff coming forward.
And what I'm really enjoying is the ingenuity as people realize JWST is going to keep being delayed, and they're finding new ways to use ALMA, to use the Very Large Telescope in Chile, to do science that was originally planned for JWST, but just bump it over into the millimeter or just find a completely different way to do it. I don't know if we still do, but we used to have a JWST command in our chat that would respond with "too soon." It's going to be dead to me until until it's like beyond the moon and actually working. There's a ride at Disney last week. Susie, Annie, and I were blowing all of my soon to expire travel points to attempt to go see CRS-19 launch and to see Starliner launch. Both launches got moved, so there were 0 launches. So we went to Disney. And I'm here to tell you, first of all, the veterans discount for Disney is the only way to go to Disney. We're very proud to have vets working on our team. Annie is one of the vets. And they have a ride they call Mission Space, where as you blast off from the planet Earth on a mission to Mars, you pass JWST prior to getting to the moon. Which is not where JWST belongs.
Right.
And when I tweeted about this, someone whose name I shall not mention responded, "I wonder what Disney knows that we don't." So these are the things that we worry about. Now, Aviva is popping in. So our next guest is in the background, waiting in the wings. We just heard the bing. So, Mark, fundraising is not new to you, and I know you have actually helped out with your local NPR station. So I would love to hear, since our audience has heard me do it a million times, your NPR plug for CosmoQuest.
Oh boy. Golly. Well, unfortunately, my NPR plug is so tuned to listening to it on my car radio all the time. Uh, but and I say, if you listen to it all, day in, day out, then why the heck aren't you contributing? and uh, but well, you've got my little recording, right? So
I do. We will be playing that
that
later
that'll
today.
be my plug. It's like this work really relies on the generosity of your listeners and the people participating in these projects, and so I just say so contribute, large or small, but contribute and let's go explore.
And that really is our goal, is to go explore. Now, you've gotten to be parts of missions before. What was it like for you the first time you got to go home and say, I'm working on a space mission?
Oh, well, I was on a lot of mission proposals. And back in the day, back in the 90s, when I was designing missions that made use of solar electric propulsion. And we were always getting smacked down because we were told that it was too risky. And so, and this went on for like 4 proposals until we until NASA finally flew. Now, solar electric propulsion, there's nothing magic about it. We've been using it in Earth orbit since the 60s. And I would go up to NASA Glenn and would work with the engineers up there to put together these missions, because they were the masters of this kind of propulsion, which is taking xenon and stripping the electrons off the heavy nuclei, shooting it out the back into the spacecraft at high velocity, and so your spacecraft gets accelerated, Newton's laws, very slowly but very efficiently. So I'd say 0 to 60 in a week, and but when we finally came up with the Dawn mission to go to Vesta and then Ceres, and the Dawn mission just ended last year. So I was involved with that for 20 years. That was very exciting. And with that propulsion, it was possible, if we'd used a chemical system, it would have been about a $2 billion mission to do. But with electric propulsion, we were able to do it for half a billion, $500 million. So it was very, very exciting to be able to have the opportunity to put something together and to watch it happen, and then the discoveries that we made in the course of the mission, going to Vesta and seeing this large, heavily mashed up surface. But a very bright surface covered with basalt, so ancient volcanism had occurred, or magmatic eruptions, but all broken up. Then you see all these dark spots on the surface, and that's from dark carbonaceous objects hitting it and then contributing that to the surface. Then we go on to Ceres, which is a dark world, so kind of flip. We see, and I was expecting this, a bright white spot because of ocean water from the interior coming up to the surface and bringing with it a lot of dissolved minerals, and then it evaporates. And when you go to Old Faithful, see these geysers and parks, what do you see? You see all the bright white evaporites that are surrounding it. And that's what we saw in Ceres. And so absolutely fascinating stuff. And Ceres is another world where it raises the question of whether there could be life in its interior, because if there's liquid water, then is there life? And we have an expanding group of locations in our solar system, Enceladus, Europa, of course, but even Mars today, where we can be asking that question. And
Vesta is one of the worlds that we did map with CosmoQuest, not in its entirety. We're just looking at certain sections. And I love seeing people in the chat mention that Vesta is essentially Bennu light when it talks to how rocky its surface is. And
I can only imagine what its surface would look like. If we got as close as you could to Bennu, then Vesta probably would have been ugly too.
Oh, I don't even want to think about that because Vesta is so much larger. And Ceres is actually the to use the online parlance, it's the OG former planet, where it was initially classified as a planet and then got reclassified, I think about 30 years later as they found more and more asteroids.
Wrong. Ceres was identified as the missing planet because, you had Bode's Law, and it was the first international campaign to go search for this missing object between Mars and Jupiter. And it was found at exactly the distance from the sun that was predicted. I mean, it was just amazing. And it was found by somebody who wasn't part of the campaign. So I was like, oh well. And but then William Herschel, he the discoverer of Uranus, the last planet to be discovered. He's going, well, it's a point of light, in the sky, and so he came up with the term asteroid. And and some people would, and then more of these things started being discovered. Vesta among them. Vesta was the fourth one to be discovered, but all of these objects, actually, when you look at the literature, continue to be referred to as planets, as a small planet or minor planet or kleinen Planeten, up until about 1953.
Oh, wow.
With more than 1,000 of them. And the reason why people kept referring to them as planets was that everybody thought that they had formed the same way that Earth and other large objects had formed. That they had all accreted, but that accretion process got interrupted when they were small. But so they thought of these asteroids or small planets or minor planets as being like the larger planets in terms of their composition and all that kind of stuff. Well, then Gerard Kuiper wrote a paper, and so you see that I was on a paper where we did statistics of how objects are referred to, asteroids are referred to from 1801, up to present, and he wrote a paper saying, asteroids were really formed primarily through fragmentation processes. They're not these primordial objects, and because now there was a change in the perspective of their geophysical properties, that they're not small eggs that just didn't grow, but rather they're pieces of things that got broken up. Then the use of calling them planets or small planets or whatever plummeted, and it was a paradigm shift in the literature. And so people talk about this stuff, but they don't. It's like a telegraph or something. These stories that go around and get repeated that really have no basis in fact. And when you go back and actually look at how people refer to things in the literature, that you see that no, people were comfortable with referring to these things as planets until like 1953. And so Gerard Kuiper was the planet killer, was the real planet killer. But interestingly, because there's this whole debate about planets and all this type of stuff, and actually what the IU did when it said, oh well, Pluto's not a planet, and other things are not planets, or dwarf planets, and dwarf planets aren't planets. It's like, okay, we need nuns to talk to them about English, usage. But what do they say? That really, they didn't change anything in terms of scientific practice, because in the literature, these objects are all, the IU definition basically is not used. That people just continue to refer to Pluto and other things as planets, but what they succeeded in doing is driving a wedge between scientific practice and educational practice and media practice. And so that's unfortunate. But more curiously, because I wrote a paper in 2009 about geophysical definition of planets. Why? And I said, when we look at all the images from spacecraft of all the worlds out there, from small irregular objects to Jupiter, when an object gets big enough to be round, by its own gravity, overcoming the mechanical strength of the material that it's made, that's when we see geology turn on. And so that's why it's a useful way of grouping things together if you're looking for common physical characteristics. And actually, that's not a new idea. That's Galileo. And I mean, he was referring to things out there because he assumed that all the things that are around were like Earth, and so manifested similar geophysical processes. We refer to the Galilean satellites as the Medicean planets. And but when you look in the literature, and this is another paper that some people are working on, that when you say, well, to what objects do people call planets? I mean, not consistently or all the time, but just in terms of just usage, and they're typing up their papers and stuff. Well, you find planet being used to refer to things like the moon, Titan, and other round objects in the solar system, because in the literature, people use it as a term to suggest that they have certain common geophysical properties. Now, no one has, well, except for a small number of people, of which I'm now one of them, because it took me a while to say, yeah, satellites could be planets too. Why not? And to get over that kind of dynamical mental barrier. But yeah, if it's big enough to be round, then why not? And if we have thousands of planets or hundreds of planets, who cares? I mean, how many stars are there? How many states are there? How many countries are there in the world? Numerosity is not important. It's characteristics that are important, and usefulness that's important. So I continue to mock the IU, but that's just fun. And I don't care what they do. They change things or not. I don't care, because people do what they do in the literature. I mean, telling scientists what to do is absolutely like herding cats. They won't listen to you.
This is true.
The IU had a definition of North Pole, right? It was the rotational axis, the pole that's in the northern ecliptic plane. And then for a long time, scientists were saying, well, yeah, but asteroids are all over the place, and so we're going to use the right-hand rule. So it's where your thumb is on your right hand. The rotation is this way, the pole's that way, whether it's down, whether it's up, or whatever. And so it was in conflict with the IU definition for decades, but ultimately the IU came around, because as with a lot of things, they should be reflecting scientific practice, not trying to impose scientific practice. So that's me. So
I see Nishi Inverse in the chat is mentioning they better not try adding the dwarf arguments to exoplanets, or I'm going to flip. You will not be the only one.
Well, I'm sorry, but exoplanets aren't planets because they don't orbit the sun.
I know.
That's
I totally screwed up. Yeah.
No,
So
we need to come up with exoplanets. That's no, yeah. I mean, in the geophysical perspective, yeah, they're all planets. I mean, come on.
So I'd like to take another break to thank people and give you a heads up on what will be coming next. So I'm going to continue talking to Mark for about 10 more minutes. Our next guest is going to be Aviva Yamani, who is the program director for our own 365 Days of Astronomy. And she is also one of the most prolific and well-known science communicators in the nation of Indonesia. And she is about to go witness not her first eclipse, but one of many. She'll be seeing tomorrow's annular eclipse in Indonesia. But before any of that happens, I want to thank Wayne Johnson and Trekker Kev for their donations. Our goal is to bring in $40,000 in 40 hours. We're doing okay for hour one, but we know that the overnight hours always slack off, so get your giving in early. Thank you. Something just happened. Thank you, Comic Girl, for the host. We are giving away so many things in the chat. Currently, there is a message deleted Twitch t-shirt available, as well as lanyards and stickers. Go ahead and type !raffle to enter. Thank you, Refs Matt, for the 100 bits. Thank you. We will be syncing bits to the ticker. There. Green screening is hard. There's the ticker. We will be syncing the bits to the ticker once an hour, once there's more people down here than just me. This is going to take an entire crew to make happen, but these early hours are when the rest of my crew is asleep. So we are ever so patient waiting for them. And Susie and Nancy are already out in the chat making awesome things happen. So thank you. More things happening. Kevlar, thank you so much for the 300 bits. You shared rewards with 3 others in the chat thanks to Twitch's holiday program. Now, Mark, with IAU and its demotion of Pluto and the chaos it has created for worlds in general, I have to admit, I have taken to calling anything that is mostly round a world, because I got tired of being smited by the planet versus dwarf planet communities, and just using the word world is generic enough that no smiting occurred, and I aim to not be smited. Now, you mentioned geophysical definitions, and this is one of those things that really is needed in so many different ways, and we keep being startled, I think is the best word at this point, by all the crazy new places we are finding geological activity to be taking place. What are some of the surprises that have really caught you off guard?
Well, one was frankly Pluto. When we flew by Pluto to see such a dynamic world, obvious subsurface oceans, you have these ice rafts that are made out of, I don't know, nitrogen or something floating around. There's mountains made out of water, ice, and because at Pluto's distance, they're rock. And it was far more dynamic than I had ever expected. And for an object that distant to be that active is really amazing, and it makes me wonder if we were to go out to Haumea, for instance, I can't get all the words right, Hamau or whatever it is, but it's spinning so fast that it's like a football, but it's also large enough to be a planet, in this case a dwarf one or a small one. And it's like, well, what kind of stuff is going on there? And other distant ones, we see nitrogen on its in spectra. So there's some differentiation, and there's some stuff coming out from the interior. And so now I've been advocate for nuclear electric propulsion. I actually proposed a Pluto mission back in the day. New Horizons won that competition, and Stern's mission was excellent. But I didn't expect to be selected because ours was a little crazy. We had a 100 kilowatt uranium reactor that was called a safe reactor, and xenon again, electric propulsion. But we're doing some simulations here recently, and we could actually get into orbit around Pluto in 8 years. It took New Horizons 9 years to do flyby chemical system, and we could deliver 3,000 kilograms to Pluto. We could deliver 3,000 kilograms on a similar time scale to orbit around Haumea and some of the other dwarf planets out there. And okay, it would be a little pricey, but a few $1 billion. But I'm thinking it'd be worth it. It'd be really cool. It'd be really neat to see. And there's also some other fast ways of getting out there that are being explored. I'm on a proposal to the NASA Advanced Concepts program, and Jeff Rayson, the former founder of president of XCore, which is another story. He's got this idea for a plasma proposal, plasma sail, which would be to couple with the solar wind, and within a month you could get up to hundreds of kilometers a second, and so you could get out to 50 AU, way beyond, Pluto's orbit in like year and a half, 2 years, and but unfortunately in that case, it'd be a fast flyby, and you can't slow down. That's the only problem with that. But we're proposing as a model mission to build this thing and then fly by Oumuamua, the first interstellar visitor that we had. Now if we could make sure that we knew where it was, then we could. He's got a way of tacking, and we could pass it. And this is the cigar-shaped object.
Yeah.
And had some, non-gravitational forces going on, like you would expect of a comet, except that we never saw a coma. So it's like, how can we see this non-gravitational stuff but not see a coma? So, does it have engines? Let's go find out. It would be a fun thing to do. And now there's the other, the second interstellar visitor that passed through the ecliptic plane on December 8th. So not that long ago. It looks like a regular comet, kind of a carbon depleted object, but it's not. It falls within the range of objects that we see in our own solar system, and so we're going to be. I think that with the advent of LSST, Large Synoptic Survey Telescope, and some other things, that we may be seeing more of these interstellar visitors passing through our solar system, and that gives us an opportunity to compare, what are these objects like compared to objects in our own solar system? What were formation conditions like in these other solar systems around other stars? We can sample these exoplanetary systems at a level, of smallness with these objects that would simply never be possible with a telescope observing a star.
And we have one last quick question from Minnesota Taz, and then we're going to have to bid adieu. So Minnesota Taz asks, what's an ecliptic plane?
Well, the orbit of the Earth, is around the sun. That defines a plane. You could imagine a piece of paper that's slipped, where the Earth is rolling on that piece of paper is the orbit of the sun. That's the ecliptic plane, and so the above, there you go, exactly, and so that's what we define as the ecliptic plane, is basically the orbit of the Earth. Now there's other little kind of variations where, let's do the average of all the planets and all that kind of stuff. Fine, that's another point. And but yeah, that's the ecliptic, and then north is, north pole of the Earth, and south is in the other direction.
And it's often described as like a set of ill-stacked dishes, and that's a poor analogy because it implies the planets are stacked up. It's more like a set of badly laid out nested hula hoops, where each planet is just slightly tilted. But overall, all of these mostly circular orbits are all in one plane of the sky.
Yeah, there's some variation. Some of the classical planets are have tilts up to several degrees, and then of course once you get out into the outer solar system and those worlds, I use Pluto and then they're a much bigger type of a thing. inclinations. The tilts of the orbits are much bigger. But that's because of dynamical history.
And this is where we're going to tie this up. Do you have any parting words for our audience, Mark?
Enjoy the show. Please contribute. This is important work that CosmoQuest supports. Like finding that landing spot on Bennu for OSIRIS-REx. And there's so much more that needs to be done. And you can actually be a real participant. Not just vicariously by watching somebody do something on TV, but to lay hands on another object. That may be digital, but you can actually be an active participant in the science that we do.
Thank you so much for being here, Mark. And
Thank
please
you.
enjoy the rest of your holiday weekend. And you will be back 39 hours from now, 38 hours from now, because you're going to be here for the last hour, first hour
Yeah.
and last hour.
Yes.
And
looking forward to it. Looking forward to success.
Okay. I will see you on the other side. And we are now going to take just a moment to swap out some of the screens while